An exponential function looks like f of x equals a to the x, where a is just any real number that's positive and not equal to 1, and that is what we call the base of our exponential function. And then we see the variable, the x, in the exponent. So that's the key thing that makes an exponential function exponential, is the variable is in the exponent. Now the graph of an exponential function looks either something like this, if that base a is bigger than 1, or something like this, if our base a is between 0 and 1. So going uphill versus going downhill. Now some properties of exponential functions that we can talk about based on these graphs is the domain of any exponential function is all real numbers, but the range, you'll notice in both of these cases, our graph stays above the x-axis. So it only takes on positive y values. So the range is 0 to infinity, not including 0. The x-axis serves as what we call a horizontal asymptote for these functions. An asymptote is just a line that a graph gets closer and closer to, but never actually touches or crosses. So in this case, as we go off to the left side, we're getting closer and closer to that x-axis, but never actually touching it or crossing it. And the same way with this one as we go off to the right side. So that's why we say the x-axis is a horizontal asymptote for these functions. Also, because it never touches or crosses the x-axis, these functions have no x-intercepts, but they do cross the y-axis at the point 0, 1. So this point on both of these graphs is located at 0, 1. And both of these graphs also pass the horizontal line test, which means an exponential function is a one-to-one function, which means it has an inverse, and we will talk about that inverse in an upcoming section. Now, if we want to be a little bit more precise with our graphs and figure out what the graph looks like for a specific base, we can just plug in numbers and plot points. So if we want to know what the graph of f of x equals 2 to the x looks like, I'm just going to plug in these different values in place of the x and figure out what y value goes along with them. So when x is equal to -1, if I stick a -1 in place of this exponent, I'm looking at 2 to the -1, which is the same as 1 over 2 to the +1, or 1/2. When I plug a 0 in place of the x, anything to the 0 power is 1. And when I plug a 1 in place of the x, that just gives me 2 to the 1st, or 2. So then I come over to my graph and plot these points. -1, 1/2, 0, 1, and 1, 2. And then I just connect those with a nice smooth curve so that I end up with something that looks like this, because in this case the base a is 2, which is bigger than 1. But now specifically I know some points that lie on the graph of 2 to the x. So then I'm going to do the same thing to figure out what 1/3 to the x looks like. When I plug in -1, that's going to flip over the 1/3 and give me a y value of 3. 0, again, anything to the 0 is just 1, and 1/3 raised to the 1 is just 1/3 back again. And then plotting those points, we have -1, 3, 0, 1, and 1, 1/3. And I connect these, and that shows me what the graph of 1/3 to the x looks like.